Ratios and similarity. Ratios are a way to compare values. Another name for a ratio is a fraction. However, a ratio can be written several different ways. When I write a fraction, which is a ratio of, say, 1 to 2, 1/2, I can write that literally how I said it, 1 to 2, or I can use a colon and say 1:2. And all three of these are the same thing. We know that 1/2 is equal to 5/10. That means that 1 to 2 is equal to 5 to 10. And just like we can reduce a fraction, for example, 5/10, we divide them both by 5 and we get that 1/2. If I get a ratio like, say, 6 to 18, I can divide both of those by 6 and say, hey, that's 1 to 3. These two are equivalent ratios. Everything you know about fractions applies to ratios. The difference is, just keep in mind, we can write 1/2, think of it as a ratio. We can say that that's 1 to 2, that's exactly the same thing. We can use a colon and say 1:2, and that it means 1 to 2. It's the same thing as 1/2. When I make a proportion out of two ratios, like 6/11 equals 12/22, there are a pair of numbers there called the means, and the other pair is called the extremes. The way to tell is to write it with a colon. 6/11 equals 12/22. These outside ones, the outside numbers, are called the extremes. And these inside ones are called the means. The means extremes property you know by another name, cross multiplication. To cross multiply, to use the means extremes property, you must have two equal fractions, two equal ratios that make a proportion, and you can cross multiply. Notice, let's take one we can see very easily. 3/6 is the same thing as 5/10. Those are both 1/2. Notice that if I cross multiply, that 6 times 5 is equal to, cross multiply, 3 times 10. They're both 30, and that's always true if the two ratios, the two fractions, are equal. And I can use that to solve. If I had a proportion like x/12 equals 9/16, I can cross multiply 16 times x, that's 16x, 9 times 12, 9 times 12, which is 108. But watch what I'm going to do here. I'm going to divide both sides by 16. And before I multiply, I'm going to cancel. I notice that 16 and 12 are both divisible by 4. I'll divide by 4 and divide by 4, and I get 3 and 4. So x is 27/4. Now this is a perfectly okay answer. If you want to say 4 into 27 goes 6 times, and 6 times 4 is 24, there'd be 3 left over, 6 3/4. That's okay too. A lot of times in mathematics, we leave our fraction improper. We always reduce it, make sure there's no common factors above and below. But an improper fraction I can divide and multiply by. A mixed number must be made improper before I can divide and multiply. So usually we'll leave it as 27/4. One of the things we use the means extremes property for, that's cross multiplication, is in similarity. Similar polygons are two polygons with the same shape but not the same size. They have corresponding angles that are congruent and corresponding sides that are proportional. And we can use that means extremes property to solve for a missing length. Let's take these two triangles. If this was triangle ABCD, BC, and this was triangle DEF, the way I write it matters. Just like with congruence, when I state that they're similar, I must line up the congruent angles. I could then say that triangle ABC is similar to, this is the symbol for similar, which is just the top part of congruence. These things have the same shape, but they're not the same size. Is similar to triangle. Now A is congruent to D, so they go in the first spot. B is congruent to E, so E goes next. And C is congruent to F, and F goes last. You can tell right from the statement which sides correspond. That only works, though, if you've stated it correctly. Here's what I'm talking about. I can tell that AB would correspond to DE. Look at the two triangles above, AB to DE. And I could write down AB over DE equals. I can tell that BC, the last two, correspond to the last two, EF. And I can see the outside to AC, it corresponds to the outside to DF. All I need then is a pair of ratios, and I can cross multiply and solve. When you use similar triangles, you line up the corresponding sides. 10 corresponds to 14. 10 is to 14. As back to the same triangle, the order matters here. The 8, it corresponds to the x. Cross multiply, 10 times x, that's 10x, is equal to 14 times 8. 14 times 8. I'm going to divide by 10, and I can divide a pair by 2. You don't, make sure you only do one number above with one number below. Divide by 2, I get 4. Divide by 2, I get 5. And x will be 4 times 14. 4 times 14 is 56. 56 over 5. And this would be a perfectly acceptable answer. This will come out to be a nice decimal. If I divide 56 by 5, I get 11.2. So either one of these would be okay. But some of the questions may ask for just a fraction, in which case you'd write 56 over 5. One more example with similar triangles. Here two triangles are similar, and I'm going to find x and y. Line up the corresponding sides. 12, it corresponds with 8. I know that because MN is the first two, and PQ is the first two in the other triangle. 12 is to 8. Back to the big triangle above, and I can say that 6, that's NO, that's the last two, it corresponds to X, which is QR, which is, again, the last two. Cross multiply and solve, 12x equals 6 times 8. I'll divide by 12, and I can divide these both by 6, and I get 1 and 2, and I can divide these both by 2, and I get 1 and 4. That means x equals 4. Let's find y now. I'm going to start off with the same pair. 12 is to 8. 12 is to 8. As 9 is to y. Cross multiply and solve. 12y equals 8 times 9. And I'll divide by 12. And these divide by 4. I get 2 and 3. I can divide these two by 3. And I get 3 and 1. Looks like it's 6 over 1, or 6. Y equals 6. The rest of this video is questions from your assignment. If you have a question as you're working through assignment, you can fast forward ahead in the video and go find that question, or one like it. Autumn has 7 dimes and 3 quarters. Write the ratio of quarters to dimes in 3 different ways. As a fraction, that would be 7 over 3. As a colon, 7:3. In words, 7, 2, 3. All these mean the same thing. Identify the means and extremes in the following proportion. To do that, we'll write this with colons. 10 is to 9 as 30 is to 27. The outside ones are the extremes. That's the 10 and the 27 are the extremes. And the inside ones, so these are the extremes. And these inside ones are the means. 9, 30 are the means, and the extremes are 10, 27. Write the ratio expressing the slope of each line. A ratio is a fraction. Slope is a fraction, rise over run. What we need are 2 points that we can clearly tell are points on the line that are at grid intersections, like right here and here. This is the rise, and this horizontal piece is the run. Pay close attention to the direction you're going. Going down is negative, going up is positive, going left is negative, going right is positive. If I start with this point, I go down, that's -2, and then right, +2. The slope would be rise or run, -2/2, which simplifies to -1. The slope is -1. Let's point out while we're at it that I could have started down here, and if I went up, that would be +2. And then if I went left, that would be -2. And rise or run would have been 2 over -2, which is still -1. The ratio of the measures of the angles of a triangle is 4 to 5 to 6. Find the measure of the largest angle. What we know is if the ratio is 4 to 5 to 6, that it's got to be equal to that same ratio, but we're talking about angles of a triangle. For example, maybe it's 8, 10, and 12. I doubled them all. That's an equivalent ratio. Or that's times 2. I could multiply by 3. 12, 15, and 18. Or I could multiply by 4. 16, 20, and 24. And I could keep going. I could multiply by 5. 20, 25, and 30. Eventually I get it. Remember, they're angles in a triangle. What I want is these things to all equal 180 degrees. What we do then is we call that multiplier. We multiply by 2 and by 3 and by 4 and by 5. We call it x. So our ratio is going to be 4x to 5x to 6x. And I know that these three things have to add to 180. 4x plus 5x plus 6x equals 180. That's 15x equals 180. And I can divide both sides by 15. And 180 divided by 15 is 12. 12 is not the answer. It's our multiplier. 4x is the first one. That's 4 times 12, 48 degrees. 5x is 5 times 12, which is 60 degrees. And 6x is 6 times 12, which is 72 degrees. The question says, what's the measure of the largest angle? That would be that one right there. 72 degrees is our answer. Here we're solving a proportion for x. Cross multiply. 30 times x, that's 30x. Cross multiply. 4 times 48. And we'll divide both sides by 30. Notice that I'm not multiplying it out because I'm supposed to find a reduced fraction, not a decimal, which this doesn't come out nicely is what I'm telling you. I can figure this out though. I know that these two both divide by 2, and I get 2 and 15. And 48 is divisible by 3. By the way, if you don't know the rule is if you sum the two digits, notice that 4 plus 8 is 12 and 48, and 3 divides the sum, 3 goes into 12, 3 will divide into 48 evenly. If you sum the digits and 3 goes into the sum, then 3 divides that number evenly. It works for 3 and 9 only, 3 and 9. These both divide by 3. I get 5 and I believe 16. Now 5 doesn't have any common factors with 2 or 16, so my answer is 2 times 16, which is 32 over 5. Here's another proportion, and it's just like the last one. The difference is when I cross multiply, I have to distribute. I'm going to take 12 times m plus 11, and I'm going to take 1 times 7, which I could have just written down 7. Distribute here. 12 times m is 12m. 12 times 11 is 132. 1 times 7 is 7. I'll subtract 132 from both sides. 7 minus 132 is negative 125. So 12m equals negative 125. I'll divide by 12. I don't believe these have any common factors. 125 is 5 times 25, which is 5 times 5 times 5. There's no common factors with 12. So our answer is negative 125 divided by 12. Question 14. Students always have trouble with questions like this, but it's just a matter of creating what you need using your equation solving skills. Understand the ratio of y to r means you want to create y over r. These two are the same. When I look at 9r over 24y, remember I want y on top and r below. There's my y, it's on top. This is over 1. I want r below. So what I'm going to do is divide by r. Now I have y over r. The problem is I have this 24 in the way. I need to get rid of that 24. I'll divide both sides by 24. The r's cancel, the 24's cancel. I'm going to flip this around. Y over r is 9 over 24. Make sure this is simplified. These both divide by 3, I believe. Divide 9 by 3, you get 3. Divide 24 by 3, you get 8. I added to the instructions on your assignment to write it as a reduced fraction instead of with a colon, although they are the same thing. So here you're going to enter 3 over 8, which is the same thing as 3 to 8, but WAMAP will want this. Here's another one, very much like the last one. In this case, I'm going to make the ratio of a to f, which is a fraction, a over f. I want a up top and f below. I'll take this equation, 25a equals 20f. I want a up top, so when I divide, I need a up top. I'm going to put f below. But I want a over f all by itself, so I know what the ratio of a to f is. I'll divide both sides by 25. That gets the a over f by itself. I get a over f equals 20 over 25. I want it in simplest form. These are both divisible by 5. Divide by 5, you get 4. Divide by 5, you get 5. A over f then is 4 to 5. Now remember, this is the same thing as a ratio, 4 to 5, but this question asks for it in fraction form, so you'll enter 4 over 5. Here we're going to find the slope of a line. This is review. The ratio is a fraction. It's rise over run. You might remember we have a formula where we subtract the y's up top. That's because the y-axis is up and down. That's the rise. We subtract the x's below, x2 minus x1, that's the run. Doesn't matter which point you start with, y2 does not mean second point. It just means it's a different y than y1. You can start with either point. I'm going to start with the first one though. M equals, my first y is -2. I'll subtract the other y, which is 10, over, below I'll subtract the x's. Since I started with the -2, I must start with the same point below, -5 minus -4. Now notice the double negative. The subtraction is separate from the negative on the 4. This is going to be plus 4 then. This is -12 over -5 plus 4, which is -1. When you divide, two negatives make a positive, so this is just 12. Similar triangles have the same shape, which means their corresponding angles are congruent. The sides aren't congruent, they're proportional. Corresponding sides are proportional. You must line up the congruent angles when you make your statement. And I see that B, it's marked with the 1. It corresponds with this one, which is the D. I can see that P, the second one right here, has 2 marks. It corresponds with F. And T, the last point there, it corresponds with Z. And I know that angle B, because it's first, is congruent to angle D. I know that angle P, because it's second, is congruent to angle F. Angle T, the third point in the first triangle, is congruent to angle Z, the third point in the second triangle. Look at the similarity statement. R is first, it's congruent to U. R is 47, U is 47. S is second, it's congruent to V, which is second, which is 89. And we can find this third angle in both cases by subtracting from 180. 180 minus 89 minus 47. That is 44 degrees. Both of these then are 44 degrees. And angle W is 44 degrees. These triangles are similar. We're going to find x. It'd been nice if they gave us a statement to tell which sides correspond, but you can tell looking at the picture. It doesn't matter which triangle you start with. I could, for example, say 35 is to x, those two correspond, as in the same triangle as the 35, as 45 is to 54, and that would work fine. Or, if you like, you could start with the x and say x is to 35. As I started with the x, I'm going to start with the big triangle, as 54 is to 45. Notice that when I cross multiply, in the top proportion, I get 45 times x, and in the bottom proportion, I also, when I cross multiply, get 45 times x. 45x equals, and then in the top proportion, I get 35 times 54, and the bottom proportion, I get 35 times 54. I'll divide both sides by 45, and these both divide by 9. I get 5 and 6, and 5 and 35 both divide by 5. I get 1 and 7. So x is 7 times 6 over 1, which is 42. The reason these two proportions produce the same cross multiplication is they're equivalent proportions. Notice in the top proportion, you get 35 over x, and see in the one in blue below, it's x over 35, how it's flipped. And in the top proportion, 45 over 54, it's also flipped below. That's why when you cross multiply, they produce the same statement. This one's a little tricky in that the second triangle is actually flipped over from the first triangle. You could probably guess which sides correspond. What they should have done in this question is also put a number right here and right here, and then students would have made mistakes, but they didn't, so that made it easier. But just notice that JK, the first two, corresponds with PQ, the first 2 points in the other triangle. JK, which is X, corresponds to PQ, which is 5.5. I'm back to the big triangle. 20, which is JL. JL are the outside two, and that would correspond with PR, which is the outside two. PR is 11. Cross multiply, 11x equals 20 times 5.5, and 20 times 5.5 is 110. 11x equals 110. I'll divide both sides by 11, and x is 10. In this question, it's really important to keep in mind that you line up corresponding sides when you make proportions with similar triangles. Notice how x in the small triangle corresponds with 31.5 in the big triangle. In the small triangle, you need another side, and they didn't give you one. You have to understand that. What I can figure out, though, is this length right here. By taking 105 and subtracting 90, that means this length is actually 15. Now I have sides that correspond. X, the height of the person, corresponds with 31.5, the height of the tree. Back to the small triangle as 15, which is this side here, and it corresponds with that length right there, which is 105. Remember, you line up corresponding sides. This side corresponds with this side. Cross multiply, 105x equals, I'm going to go ahead and multiply those. 31.5 times 15 is 472.5. I'll divide both sides by 105. 472.5 divided by 105 is 4.5. It says round to one decimal place, that's the 10th if needed. We didn't need to here. Our answer is 4.5. Question 32 is one of those flagpole questions. You have a flagpole. Here's my flag. And it casts a shadow that is 15 feet long. At the same time, I have a wall that is 35 feet high, and it casts a 7-foot shadow. I need the height of the flagpole. These are similar triangles as long as it's the same time of the day. And I know that X corresponds to 35. That's the height of the flagpole, the height of the wall. Back to the same triangle with the X, as 15 corresponds to 7. We'll cross multiply. 7x equals 15 times 35. And we'll divide both sides by 7. 7 goes into 35 5 times. X is by itself, and 5 times 15 is 75. X is 75. The height of the flagpole is 75 feet.